So today we're going to derive the SUVAT equations, the 5 SUVAT equations. So we already know the equations that S equals to ut plus 1 half at squared, v equals to u plus at, v squared equals to u squared 2as, s equals to 1 half u plus v into t, and the last equation vt minus 1 half at squared. So I assume that you all know these equations by properly, and you have a great understanding of those equations. And today I'm going to derive formally these equations. So if I derive the first equation, this equation first, let's use a different color for the derivation. Let's use a white color. Let's use green color for the derivation. Okay, so if you look at the velocity time graph, the velocity is measured in meters per second and time measured in seconds. So you already know that these equations are only applicable if you assume the acceleration is constant. So if this is u and this is v, then this is first after some time t. Okay, we know that the gradient of the velocity time graph is the acceleration a. So if I use the gradient formula, like a equals to the difference in the y values, v take away u by the difference in the x coordinates, t take away 0, which is t. So if I solve this equation, if I use algebraic techniques to make v the subject of the formula, I get v equals to u plus at. So this is the first, the first SUVAT equation. V equals to u plus at, where v stands for velocity, the final velocity, u is the initial velocity, a is the acceleration, and t is the time taken. Now let's derive this equation, this one. Let's derive this one. So you can see that we all know that the area underneath the curve of a velocity time graph is displacement. So if I use the trapezium formula, which is 1 half, look, 1 half, the sum of the parallel sides, u plus v, and this is the height into t. So the equation becomes 1 half u plus v into t. So we have derived this equation formally. Now let us derive the third one. Let's derive this equation, s equals to ut plus half at squared. For that, you'll need these two equations, u plus at, and s equals 1 half u plus v into t. Equation 1, equation 2. Make v the subject of the formula, so this becomes equation 3. So substituting v into v u plus v u plus at into t. Now 1 half 2u plus at into t. Now if you multiply this, you will get ut plus 1 half at squared. The third SUVAT equation we have just derived. Now let's derive the fourth one. Okay, let's derive this equation: v squared plus u squared plus 2as. For that, you will need these two equations: v equals to u plus 80 and s equals to 1 half v plus u into t. So 1, equation 2. Make t the subject of the formula of equation 1, v minus u by a, which is the third equation. Substitute t into the second equation, u plus v into t is v minus u by a, so v plus u, v minus u divided by 2a. So v plus u, v minus u is the difference of 2 squared. We know that a squared minus b squared is a plus b, a minus b. So v squared minus u squared divided by 2a. So v squared minus u squared 2as, v squared equals to u squared plus 2as. So the fourth SUVAT equation. So 1, 2, 3, 4, the fourth SUVAT equation. Okay, fifth SUVAT equation. Sorry, 1, 2, 3, 4. The fourth. We have 1, 2, 3, 4, 5 equations. We have derived four equations. Now let's derive the last one. Okay. Now let's derive this particular equation. For that, we will need the same equations, at and s equals to 1 half u plus v into t. Now make u the subject of the formula of the first equation, v take away at. So this is the third equation. Substitute the value of u into v minus 8t plus v into t, s equals to 1 half v minus 2v. Let's make it more explicit and clear. So s equals to 1 half 2v minus 8t into t. So if we use algebra and multiply half with 2v minus 8t into t, I'll get vt, sorry, not ut. I will get vt minus half at squared. So this is our last and final SUVAT equation. So I hope you like this video, and please don't forget to subscribe this video and share it to your friends. Remember, these equations are only applicable if you assume the acceleration is constant. Okay, bye.